In this video, I'm going to finish going over the mock. So this is your mock paper. This is the statistics section. So we got as far as doing all of the pure. Let's finish the statistics section. So Joseph drew a histogram to show information about one local authority. He used the data from the age structure for a large data set. Now, we need to find the height of the histogram. So hopefully you all first wanted to find the frequency density, which is frequency divided by class width. Now the problem is my class width on this one is not 4. My class width is 5. When we have data like this without any less than or equal to signs, in other words, without being an inequality, we've got to assume that the data is actually, we need the upper bound and the lower bound. So we'd have minus 0.5 all the way up, not including 4.5. And the gap between 4.5 and minus 0.5 is actually 5. So my class width is bigger than what you were thinking. How do you find frequency density? Well, we do 2143 divided by 5, which comes out to be 428.6. Now, it's 1 centimeter is 1,000 units. So we need to divide this by 1,000, which tells us we get 0.429 centimeters to 3 significant figures. Okay, so most of you that got it wrong, it was all about this class width. The class width is actually 5. So unless it's given to you like this, you've got to add 1 to your class width because of upper bound and lower bound. Right, Magdalene, which draw a statistical diagram for the method of travel. Why can she not draw the histogram? Because it's non-numerical data. You had to basically say there were no numbers. So that's what we're looking for. Or you could have said it's qualitative data, not quantitative data. But anything to actually say that it's not numerical data was what you needed. Right, question 9, we had to find an estimate of the mean. Right, how do we estimate the mean? Well, we do midpoint times frequency. So we're going to do 0 times 7, 1 times 12, 3 times 9. Halfway between this is 7.5 times 1. Halfway between these two is 15.5. Halfway between these two is 25.5. And then we multiply these across. That gives us 72 when we add all those up together. There are, if you add all of these, 30. And 72 divided by 30 is 2.4. Most of you got that one right, so that wasn't a big issue. Right, the head teacher writing a report on the number of absences at a school. She wishes to include a figure for the average number of absences in class A. She should quote the mean. Okay, so why should she quote the median and not the mean? Well, the most obvious thing is to look at, are there any outliers? Absolutely. This one here is so far away from the next one down that is considered an outlier. Now, they were very picky in the mark scheme about this one. You had to say we'd use the median as it is less influenced by the outlier. And now here comes the clincher, the problem. In the 21 to 30 class, you had to mention that that was where the outlier was. Otherwise, you didn't score your mark. That's the annoying thing about stats, is they are very picky with words and things. Okay, so you had to mention that the median was, the outlier, sorry, was in the 21 to 30 class. Question 10. Right, so once again, we are back in our large data set. So there were quite a few large data set questions, but most of you managed to score well just from using your logic. In one of these 4 LAs, local authorities, a new tram system was opened in 2004. Which one was it? Well, that means I'm going to be looking at this column here. So where is there a sharp increase in the number of users between 2001 and 2011? Now, it's very tempting to look here because, there is an increase. But have a look at the increase in the population. It's quite substantial, which means there's bound to be an increase in all of those. However, if you go down to local authority 4, there's a bit of an increase in population, agreed, and there's an increase in all the others, but there's a substantial increase here. It's our biggest percentage increase. So the reason is LA4. And why? It increased from 65 to 2495. It is a much bigger increase than all the others. Anything like that. So 1 mark for saying LA4, 1 mark for this. There was a huge increase. If you didn't get the fact that it was the LA4, you wouldn't got any marks whatsoever. Question B. Julian suggests by the figures for bus, minibus or coach for LA1 show that some new bus routes were introduced. Use the data from the table. So they're actually telling us here they want us to look at the data. They want some figures from the data. So let's have a look. Now, LA1. There's LA1. We've got an increase in population. Now, if you want to be smart about this and you've got the time, so this does depend on the time, you can work out what the ratio is. So on your calculator, if we just put 79 to 118, I've truncated the numbers because all I'm looking at is a ratio, and 79 to 118 is not going to be a particularly, I don't think it'll simplify actually. No, it doesn't. I could also write that as in the ratio 1:2. So 118 divided by 79 tells me the ratio is roughly 1:1.5. That's roughly the ratio. Let's have a look at the ratio of the bus. We've got 20 to 30. What's the ratio of 20 to 30? It's 1:1.5. Can you see that these are the same ratio? In other words, the increase in the number of people corresponds with the increase in the bus or minibus or coach. So therefore it's unlikely it's new bus routes. It's far more likely that it's just the increase in population. So how do we actually answer this question? What were they looking for? They wanted you to say something like the ratio for the bus is approximately the same as the ratio for increase of people. Okay, I should have said the ratio of increase for the bus is roughly the ratio for the increase of the people. So it doesn't help. Therefore we can say there's no reason, because we had to comment on our suggestion, there's no reason to indicate new bus routes. Okay, not many people got that one right. Right, next one. In one of these 4 LAs, a congestion charge. Right, if you don't know what a congestion charge is, you've obviously never been to London or know anything about the congestion charge. Basically, they charge you in the high congestion areas for just driving your car into those areas. So London's definitely got a congestion charge zone. And the whole idea is to try and reduce the number of cars going in. So what we're looking for is something in the data that says that much fewer cars went in 2011 to 2001 because it was more expensive to drive your car in those areas and therefore people wouldn't. So looking at those local authorities, and we're looking at the car now. So driving a car or van. Which one of these has seen a decrease less people driving. And hopefully you can see it's this one here. So our answer happens to be LA1. And this one's quite easy to say. It's the only one with a decrease. Decrease in the number of cars or vans being driven. Hopefully that makes some kind of logical sense to you guys. Right, question 11. Okay, we knew this one was coming. You are fairly guaranteed one of these in your end of year exams in September next year. No, what's June? June next year. Your A-levels. You are very, very likely to get one of these. So it is known that under the standard treatment for certain disease, 9.7% of the population experience side effects. One assumption needed for a binomial. Now, what do we need for a binomial? We need there to be a fixed number of trials. We need to be success or failure. Each trial needs to be independent of all other trials, and the probability needs to remain constant. Now, we're not going to say there's a fixed number of trials because they've already told us there's a fixed number. They told you there was only 450 patients. So that's irrelevant. We're assuming what? Well, in this particular case, we're assuming that the probability of side effects, because that's what we're talking about, is the same for each patient. In other words, the probability remains the same. You could also say that the patients or cases are independent. So you could either use the independent one or the fact the probability doesn't change. Now, question B is our delightful hypothesis testing. So let's go through all the little bits that we've got to have, and I'm going to take you through where the marks are rewarded for this. So first thing you need to do is set out your H0 and your H1. H0, H1. So remember, H0 is what the base hypothesis is. What should it be? And the base hypothesis is that the probability of having side effects is 0.097. We much prefer it in decimals. Now, we've got two choices on this one. Well, three actually. Either it's not equal to, or it's less than, or it's greater than. So the proportion of the patients experiencing side effects within 1 year is greater. Greater. So that gives us a hint. We were looking at 0.097. Now that wouldn't score you 2 marks yet. You needed to say what P was. P is the proportion of patients experiencing side effects. Within a year. That statement there would guarantee you 2 marks. If you just got one of these statements, you got both of these statements but not this, you'd only have scored 1. Right, next thing, we need to state that it's binomial. So we're saying X is binomially distributed with 450, because that's 450 patients, and we write the probability in here. Okay? And we are looking at X being 50 or 51. So in this particular case, because why are we getting 50? We say 51 of the patients experience side effects 1 year. We want to know what is the likelihood that 51 or more patients are going to get that. So this combination here would have given you your second mark. We now need to find this. Well, our calculator doesn't work in greater than, it works in less than. So we're going to do 1 minus the probability of X being less than or equal to 50, because that's the opposite. If you put that into your calculator, and remember you do that using your binomial CD button, and we use variable, you should have got 0.862. When we take that away from 1, we get 0.138. And that gives you another one. So these ones are B1 marks, but remember you need that. This gives us our M1, combined with the fact that we're looking at 51. Here, we get our first answer mark. Now we need to compare this. So we need to say 0.38. Now this is where we get to the 10%. 10% is 0.1. This is bigger than 0.1. So that gives me my A1 follow-through mark. So now I've compared it. What does it mean that it's bigger? That means it's more likely to happen. And if it's more likely to happen, then it looks like we might be right. There might be a greater chance of having side effects. So what do we say?